Welcome to the Unit 5 Lesson 4 video. There aren't any handed out notes for this video, but you should be able to follow along on a piece of paper or on just a scratch piece of something else. If you want to follow along, you should definitely be taking some notes. Here's a review of all of the rules that we know with exponents. These will be very helpful for you as you review for your test on Friday. Notice that we have the product of the powers rule, which means when you multiply by the same base, you will add the exponents. An example might be x to the third times x squared would be x to the fifth power, because I just add 3 plus 2 to get 5. The quotient of power, that's something you get when you divide. A product is what you get when you multiply. If I divide by the same base, I will subtract the exponents. For example, if I had the same numbers, x to the third divided by x squared, well, that would be x to the first power. That's 3 minus 2. If I take a power to a power, I'll multiply the exponents. I won't go through all of these, but make sure that you're familiar with it. The one I will go through, x to the negative m, is the reciprocal, or 1 over x to the positive m. If you have a negative exponent, you'll switch sides of the fraction, make it positive. This video is going to be about how to solve for a variable inside of an exponent when I'm multiplying or dividing with the same bases. Now, when I multiply by the same base, I just got done telling you that I will do what with the exponents? Add them. Now I have z to the 3 plus a equals z to the 4th. Now, in order for this equation to be true, I want both sides to be exactly the same. In order for them to be exactly the same, the base and the exponents have to be the same. So the base is already the same, so the exponents have to be set equal to each other. And I solve by subtracting 3 from both sides. A is equal to 1. And that makes sense. If I put 1 in for a, z to the third times z to the first should be z to the 4th. Some of you might be able to figure that out without doing any algebra. But sometimes you'll get harder ones like this. Z to the third raised to the 2 times a equals z to the 54. Now if I take a power to a power, what will I do with those exponents? Multiply them. So this is z to the 3 times 2 is 6a equals z to the 54th. And now you should be able to find out what that is, because 6a, the exponent, has to be equal to 54, the exponent on the other side. Because the bases are the same, and they're on the other sides of an equal sign, the exponents have to be the same. If I divide by 6 on both sides, a should be 9. If you want to check to make sure you did it correctly, plug it in. Z to the third raised to the 2 times 9 should equal z to the 54. Let's double check. 2 times 9 is 18. Oops. 3 times 18, just in case you didn't know that, 24. Then it'd be 54. That was a really bad 5. 3 times 1 plus 2 is 5. 54. Okay, it worked. Let's do 1 or 2 more of these. In this case, power to power means I multiply the exponents. 4 times 2 is 8 times a times p to the 4th. Now, 1 over p to the 12 would be p to the negative 12. That's because this is the reciprocal of the positive exponent. If I multiply by the same base, what do I do with that exponent? Add it. 8a plus 4 equals p to the negative 12. If these are going to be equal expressions, if they have the same base, their exponent has to be the same. 8a plus 4 equals negative 12. If I solve, I get a. 8a equals negative 16. A equals negative 2. Plug it in to make sure. P to the 4th raised to the 2 times negative 2 times p to the 4th. Let's see what that gets me. P to the 4th raised to the negative 4 times p to the positive 4, p to the negative 16 times p to the positive 4, p to the negative 12, which is 1 over p to the total power, so it works. And the final example from this video is a real doozy, but if you just take it one step at a time, it's not as hard as you think. First step is I want to take the power to power, so I multiply. Y to the fifth stays the same times 3 times 4 is 12 times z, all divided by y squared equals y to the 27. Now let's combine the numerator's exponents, multiply by the same base, add the exponents, 12z, and then it's going to be raised to the, oh, I'm sorry, made a small mistake there. It's going to be y to the 5 plus 12z, because I add the exponents, divided by y to the second power. What happens when I divide by the same base? I subtract the exponents. This will be y to the 5 plus 12z minus the 2 from before. So I took the numerator exponent minus the denominator exponent, because I was dividing, right? Equals y to the 27. Now I set the exponents equal. Notice I have like terms. 5 minus 2 is 3. 12z plus 3 equals 27. I subtract 3. 12z equals 24. Z equals 2. That's it. Hopefully that made sense. If you need to rewatch the video, make sure you do that. Have a good evening.